Hello again. Here I am on the trail, a little bit past those rocks that I showed you. In fact, they are right down there. You can sort of see them side by side. At any rate, I wanted to talk about the physiographic region that we're in right now. This is called the Basin and Range. And somewhere in the neighborhood of, I believe, and I might be wrong, but somewhere about 8 million years ago, I believe, somewhere 8 to 10 million years ago, the North American continent, right here where Utah is, began to split and move westward. The Rocky Mountains, which are right there, the Wasatch Range, pretty well stayed put, but everything to the west of here, as far as the Sierras, began to expand westward and stretch. And of course, it's kind of hard to stretch rock without cracking it. So what ultimately happened was massive, gigantic blocks of rock began to move westward very, very slowly. And as they moved westward, some of the blocks sank and some of the blocks rose. And so you have these mountain ranges, like there you have the Promontory Mountain Range. In the distance, the snow-peaked, is it called the Owens Range? I'm not entirely sure, but it's right on the Idaho border. And then across the lake there, you can see mountains heading toward Nevada. And then, of course, we're on Antelope Island, which is itself one of those massive blocks of rock that has risen to over 6,000 feet with Freyre Peak. And then in the distance, you have the Rockies. Well, the reason the Great Salt Lake is where it's located is that's where the blocks of rock, the massive, massive blocks of rock, sank. And below the lake, you have sediment. And if you drill down through the sediment, there are areas of the sediment that you have to drill down 2 to 3 miles before you actually hit the bedrock. That's how far the bedrock has sunk in the last few million years. So what causes these movements? Well, they tend to stretch, and they know how fast they're moving because they have very accurate laser ways to measure it. But every once in a while, along places like the Wasatch Fault at the base of the Rocky Mountains there are earthquakes. And with each earthquake, the rocks move a little bit. Sometimes they sink. Sometimes on the other side of the fault, it might rise slightly. But at any rate, over long periods of time, you wind up with mountain ranges and you wind up with basins. So if you look at a map of the United States, especially a physiographic or a topographical map of the United States, you will see Nevada has what amounts to stripes of mountains north to south with valleys in between. Each of those mountain ranges is a gigantic block that has risen, and between them in the valleys, below those valleys, are giant blocks of rock that have sunk. So from here, the Wasatch Range, all the way to the Sierras of California, you have this Basin and Range region, which is very geologically active. And it's continuing to stretch, and it's moving more or less in a west-northwest direction. And so, yeah, I think it's pretty fascinating. Whether at some point in time there's a new ocean that opens up here, that's anybody's guess. Could be that it'll split open and western part of North America will just break off from the rest of North America. We don't know, but it's kind of fun to speculate. So there you have it, the Basin and Range. And by the way, this physiographic region we're in is the Basin and Range. But right over there, you can see the snow-capped Wasatch Mountains. Those are the Rocky Mountains. So when you cross from Salt Lake City into the Rocky Mountains, you actually are going from the Basin and Range physiographic region into the Rocky Mountain physiographic region. And the Rockies are actually much more stable than the Basin and Range area. So there you go.